Ladies and gentlemen, welcome to my new shop. My name is Keith and I am your host. The Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, on with the show. Alright, and what diameter we have here now is like 2,475, and we got to go down to 2,239, something like that. We got a lot of material on here, so let's see what we got. Okay, we just finished taking a cut there, and we got 292, and we're gonna finish up at 238, 39, somewhere around in that neighborhood. So we can look. We got a nice clean surface. A couple little spots in there, right there, but that's gonna be a little valley in there. This will be finishing off flush there. That's almost to that diameter. So we got a material built on there. These chips are hard. This material is way tougher than I thought I was gonna get, but it looks doable. Okay, I got the spline set up, and we picked our cutter. We're gonna rough out the root of the teeth. We've already gone around the outside, and this index does 10 to 1, so basically, or 5 to 1. So we're splitting 50 holes, 50 holes, 50 holes, 50 holes, and that gives us our 10 positions of spline count. All right. I just wanted to touch up here. We got a lot of noise going on in here, so I wasn't going to do a video right now. We've gone around. We have 10 root passes to depth, and we're sure that we came across and we cleaned all the way to here. This is where that comes into a little bit at this edge right here. We're not worried about that. It was cut up into here before. That's why we had to weld, build, and remachine this as well. This relief has nice radius in here. It comes in, and it's going to serve its purpose there. All right, now that we have a root down to the diameter we want, we need to create straight spline on each one of these. Now there's two ways to do this, and you could rotate this and make a spacer and come in and have a cutter cut the top and the bottom at the same time. But what we're going to do is we're going to leave this cutter right in here. We're going to index this to split the difference, and then we're going to take this diameter of, or the width of the cutter, which is 240, and the width of the tooth of spline we want was 348. So we end up half of each of those is 120, 174, 294. So 294 from center position right now, above and below the tooth is where we're going to position this cutter, and then we're going to, after we come in with a cut, we're going to be able to set our depth, because we're going to see how the bottom of the cut comes in play with the root. And we want to leave the root what it is in the middle, but we can come in, and the corner of the cutter can come in and cut just a little deeper on each side. It'll be basically an angle change is what it'll be, but the tooth is going to be straight. All right, So I'm just doing a quick video with the phone because I need to keep moving on this, and I'm almost done. Wrap it up and we'll be able to send this thing out tomorrow. All right, let me show you how we're going to index this halfway. Okay, we've been running the first pin up here and a pin 180 over here, and we've been switching this out and rotating it like that much to that much to make a whole tooth. So what we've done is we've counted out the holes 25 this way and 25 this way, or 25 from here to there or here to there. It's equal. So these two marked holes right here are 25 and 25, which will be halfway between there. So we're going to switch up, and we're going to work these two holes here. All right, that one there, and that one there. And we use the same guide to lock into our holes. All right, we're going to lock that. All right, so we're all set here. We're going to start at this position here, and that puts that tooth out here in horizontal position. And our cutter, you can see that our cutter is splitting that tooth right in half. So now we're just going to move up our 294, and we're going to go ahead. We're going to work the top first because it's going to be easier to set our depth, and then we're just going to leave our depth set for when we shift it and we go down for the bottom. We're gonna go ahead and we're gonna hit it just a little bit on the high side. We'd rather start out with a fatter tooth, and then if we have to, we just have a polishing cut that will allow us to bring it down to the final size. All right. Okay, we're all the way around, and this tooth section right here, we're getting 3 inches 48, and we're taking it, we're miking it right here with the micrometer. Okay, and to me that's measuring about 2/1000 under what we got on the with the veneers or the dial calipers inside the opening on the coupling. So I'm going to pull off the tailstock here, and we're going to try this. Now I'm going to take my Scotch-Brite, and we're going to hit these leading edges right here because they have a little tiny bit of a burr on some of the areas. Not bad. Let's pull the tailstock off here. And hopefully we don't have to reset that again. Okay, moment of truth here. Ah, hot damn. All right, we come in here for our last step before we get this in the mail this afternoon. We're kind of putting the push on really getting this out today. All right, we've got a good fit between our coupling and our spline now. Now we need to try to bring some hardness to the teeth. This, I'll set this in here real quick. There we go. And tighten that up. This is when you don't want to have any accidents. All right. Something I learned a while back when I had that drive gear for my K&T for the universal head, I was missing that gear. And I went to the gear house. Worcester Gear was where I went and had them cut the teeth. They are helical cut teeth. They're kind of special. I wasn't able to do them myself. But I dropped it off and I made the blank for that gear out of the alloy. They told me to bring it. They also asked me to bring the mating gear to that, which is the gear that's in the head itself. And I learned that in a gear train, all the gears are supposed to be hardened to different hardnesses so that the wear or the lack of wear or accidental breakage and things like that come into play. I don't know all the details, but I do know that gear trains have different hardnesses as they progress through the chain. I don't know if they go up or down on hardness. That's just not my deal. I know that I can put a mar in on this piece here, and the hardness in that shaft is designed to keep that alive and this be the waster part in a sense. All right, so all I want to do is I want to try to get some hardness out of that 118 rod that I put in here. That rod is harder than mild steel, but I got to treat it as mild steel. What I want to do is use my Casent surface hardening compound, and I've done cold roll 1018 parts, surface harden those for different jobs along the way. This can I probably purchased back in, I think I was working on Larry Mahan's boat, and we made some rocker arms out of some pins for the rocker arms on the old Wolverine engine there, and we case hardened the surfaces on those. And this can here, I think I did that back in probably 95, 96. So we're gonna heat that up red hot. That's what for mild steel, heat part uniformly to a bright red, approximately 650 degrees. Dip or roll in the compound to form a uniform shell around that area to be hardened. Reheat to a bright red. Quench immediately in cold water using scrubbing action to ensure cooling rate. We have a tub down here with water on the floor, and of course getting that and trying to dip that into the can is going to be a little rough, so I'm going to dump this out right here on this sheet of metal so I can reclaim that and put it back into the can. But this gives me an open area to go ahead and roll that spline in there to give it a coating, and we're going to slip it back in here and quench that, or bring it to a bright red again, and then quench it. And then if we get some results out of it, we're going to be totally happy. And if we don't get any results out of it, we're gonna send it as is, because it's everything that we can possibly do to rejuvenate a piece of junk to start with. All right, let's get some heat going. We're getting close.
I was using my infrared here, and it'll get me down in the cold sections here. But up here, it just says high. I think the batteries are starting to go in that thing. That's another thing. Temp skips don't have batteries. But we're going by the colors. Get a few things ready here.
Okay, let's take it. We're gonna roll it. Okay, we got a coating on it, even though some of it looks like a powder. We're just gonna tighten up these two that we loosened here. Okay. She really hasn't lost much of that color, so.
Of course, now we can't see nothing. Just like brazing. Okay.
Okay. Now we take it and quench it. And you do a scrubbing action. Okay, we're going to set this here. We're going to let that cool down now. All right. Whew. All right, she's still warm down here to touch. She's actually colder here, or cooler here than she is over here now. Heat is transferred over there. And I'm just going to I'm going to scrub up the coating that was kind of sticky on here. And we're going to get this nice and presentable. Well, it really looks like a nice hardened gear, the color wise anyway, but that's just the materials. Looks pretty good, huh? I think so. Okay, now the question, did we make it harder? Maybe a little. It's scratching off. No, I think we made a difference. We did. We can take that black coating off of there, but it's not putting a groove in it. And for you commercial Nazis, Casent surface hardening compound for case hardening iron and steel. Number 1. 46 years in my experience, right here in this one can. Okay, one last thing, and a lot of times you get asked this, and also it was one of my questions. And when you heat treat something, does it change its size and this and that? And actually, I checked this a little bit when it was warm, and it wasn't wanting to go on there, but it goes all the way on there, and it's a little firmer. And I think it might even be because of probably just a little bit of. But you can't hate that fit, that's for sure. Alright. Good fitting spline. Alright. Wasn't able to fully capture everything 100% on the way, but I think I filled you in on all the details and anything that might be unusual or that I thought was important to bring you in on a job in and out of the shop. We're going to get this wrapped up, and it's going to go back up to Caribou, Maine. All right, till the next time, get her done.